بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. I'll continue exercises about section 4.1, which is about maximum and minimum values. And these are exercises about critical numbers. Find the critical numbers of each function. So we have seen that first step to find the critical numbers is to determine the domain. Here we have cube root. So there is no problem with the cube roots. The domain would be all real numbers. Now to find f prime, we have a product, so we will use the product formula. The derivative of x to the power 1 over 3 is 1 over 3 times x to the power 1 over 3 minus 1, which is negative 2 over 3, times 4 minus x to the power 2 over 3 plus x to the power 1 over 3 times the derivative of the second function, which is 2 over 3 times 4 minus x to the power 2 over 3 minus 1, which is negative 1 over 3 times negative 1, the derivative of 4 minus x. And now to simplify f prime, we need to take common factors. And you need to look to take common factors. Look first to the numbers. I have 1 over 3, I have 2 over 3, and the negative sign here. So I can take 1 over 3 as a common factor. Now look to x. I have x to the power negative 2 over 3, x to the power 1 over 3. Take x with the smallest power, which is negative 2 over 3 as a common factor. And I have this 4 minus x to the power 2 over 3, negative 1 over 3. The smallest power is negative 1 over 3. So you take it as a common factor. And then we open parentheses and start dividing the first term of f prime by this common factor. So 1 over 3 cancels, x negative 2 over 3 cancels, and we will have 4 minus x to the power 2 over 3 minus 1 over 3, subtracting the powers when you divide. So 2 over 3 plus 1 over 3, 1 over 3, which is 1. Good. So we finished taking the common factor from the first term. Now the second term, remember there is a negative 1 here, so I can write it now. And 2 over 3 divided by 1 over 3 will give me 2. Okay, what about x to the power 1 over 3? Divide by x to the power negative 2 over 3. You will have x to the power 1 over 3 minus 2 over 3, 1 over 3 plus 2 over 3, which is 1. And 4 minus x to the power negative 1 over 3 has been taken. So that's it. So now I have, this would be 4 minus x minus 2x. So I'll have 4 minus 3x, and all the others are in the denominator. 3 is in the denominator, and x, I will take it down to make the coefficient, the power, the exponent positive. So this is f prime written in simplest form. And now I search for two things. What are the values of x that makes f prime does not exist? I look to the denominator. What are the values that make the denominator 0? Well, if you put it equal to 0, then x to the power 2 over 3 equals to 0, which means x is 0. So 0 will make this 0, and the denominator would be 0. Also 4 minus x, if you put x4, then I'll have 4 minus 4, and that's 0. To the power 1 over 3, it would be 0. So two values will make f prime does not exist, and the denominator is all real numbers. So these two values are in the denominator of f. Okay, now f prime equals to 0. Well, this is f prime, and it would be equal to 0 if the numerator is 0, because it's a fraction, you know. So x would be 4 over 3. So 4 over 3 will make the numerator 0, and it belongs to the domain because the domain consists of all real numbers. So critical numbers of f are 0, 4, and 4 over 3. 3 critical numbers. Another question. Let us determine the domain first. Well, x squared, no problem with it, all real numbers, but ln x, ln x has to be greater than 0. So the domain is from 0 to infinity. 0 is not accepted. Len 0 is not defined. Okay, let us start finding g prime. A product. So use the product rule. 2x times ln x plus x squared times 1 over x, derivative of ln x. So it is 2x ln x plus x squared over x is just x. Take common factors. X is the only common factor. And I have 2 ln x plus 1. So this is g prime. Okay. Now, g prime does not exist if x is 0 or negative, but these values are not in the domain, not accepted. So we will deal only with g prime equals to 0. So let us put x times 2 ln x plus 1 equals to 0. So either x is 0, so this is one solution, or 2 ln x plus 1 is 0. And we have to solve this equation. So we take 1 to the other side, we divide by 2, and then we raise both sides to the base e. So x is e to the power negative half. Is it in the domain? Yeah, it is 1 over e to the power half, and that's a positive number. It's not negative. So it belongs to the domain of g, and 0 or 0 does not belong to the domain of g. So 0 cannot be a critical number because it's not in the domain of g. So the only critical number of this function is e to the power negative half. Now other type of questions, find the absolute maximum and absolute minimum on a closed interval. This was the last part of section 4.1. So please watch the section first if you don't remember how to solve this exercise, or just listen carefully. Well, to find the absolute maximum or the absolute minimum and the absolute minimum, we do the following. First, we find the critical numbers. And to find the critical numbers, now we have an interval to deal with. Only the critical numbers inside the interval from 0 to 5 will work. So f prime x will be 4 minus 2x. F prime cannot be, it's always exists, no denominator. So we have only the values that makes f prime zeros. 2x would be 4 or x is 2. And 2 belongs to the interval 0 and 5. So now we make a table. All the critical numbers that we found between 0 and 5, 2, the only one was 2. And we also put the end points of the interval. And we find f of x for each one of these numbers. So f of 0 is 12. And f of 2 would be 12 plus 2 times 4, 8, minus 2 squared, which is 4. So the answer is 16. And 12 plus f of 5, 4 times 5, 20, minus 5 square, or 25. The answer is 7. So the absolute maximum of f in the interval 0 to 5 is f of 2, which is 16, because 16 is the largest value. And the absolute minimum in the interval 0, 5 would be f of 5, which is 7. So we solved the question. Another question, similar. Let us find the critical numbers. 6x squared, 6x minus 12. It always exists. So let us find the values that makes f prime 0. Divide by 6. So x squared minus x minus 2 is 0. Factor. So either x is 2 or x is negative 1. Both of these numbers are between negative 2 and 3. So I make a table. I put the critical numbers 2, negative 1, and I put the endpoints of the interval negative 2 and 3, and I find f of x. And I replace, okay, f of x. I replace x by 2, find the answer, negative 1, negative 2, 3, find the answer. And the largest would be the absolute maximum, the smallest would be the absolute minimum, exactly like here. Please continue this question and find the answer. Another question. So we start immediately by finding f prime 12x to the power 3, 12x squared, 24x. Well, put it equal to 0 and find the zeros of the derivative. Divide by 12 and take x as a common factor. So I'll have x squared minus x minus 2 will again minus 2 plus 1. So the critical numbers are 0, 2, and negative 1. Now, all of these numbers again in the interval from negative 2 to 3. So make a table, put all the critical numbers and the endpoints of the interval. Find f of x for each of them. For example, f of 0 is 1. And the largest value of f of x would be the absolute maximum, and the smallest would be the absolute minimum. Please continue the question. Well, the domain here is all real numbers except 0, but 0 is not in this interval. So f prime of x would be 1 minus 1 over x squared. And if you write it, if you add these two fractions, you have x squared minus 1 over x squared, or x minus 1 times x plus 1 over x squared. Notice that f prime does not exist when x is 0, but 0 is not in the domain of f. And f prime is 0 when x is 1 and x is negative 1. Well, 1 and negative 1 are in the domain of f, so they are critical numbers. But negative 1 does not belong to the interval from 0.2 to 4. So I'm not going to take it into consideration when I make my table. It's a critical number, but it is not inside this interval. So the only critical number that works is the 1. and I have 0.2 and I have 4, the endpoints of the interval. If I replace x by 1, 1 plus 1, that's 2, and 1 over 0.2 is 5 plus 0.2, so this is 5.2, and 1 over 4 is 0.25 plus 4, so that's 4.25. So the absolute maximum of this function inside this interval is f of 0.2, which is 5.2, and the absolute minimum in this interval is f of 1, which is 2. It occurs at the critical number. Same question, different function, different interval. So let us find, well, the domain here of this function is from 0 to infinity because this is ln x. So domain of f is from 0 to infinity. Well, f prime of x is product. So derivative of x to the power negative 2 is negative 2x to the power negative 3 times ln x plus x to the power negative 2 times 1 over x. So this is negative 2x to the power negative 3 ln x. And if I raise x up, so I have x to the power negative 2 times x to the power negative 1. When you add the powers, you have actually x to the power negative 3. Take a common factor, which is x to the power negative 3. So I will have negative 2 ln x plus 1. So f prime would be negative 2, or I can write it 1 minus 2 ln x over x to the power 3. Now f prime does not exist at 0, but 0 does not belong to the domain. And f prime is 0 when 2 ln x equals 1. 1 minus 2 ln x equals 0. So when ln x equals half, or x equals e to the power half. Well, if I find e to the power half by calculator, it is 1.65, approximately 1.65. And 1.65 belongs to the interval 1 over 2 and 4. So the critical number, this is the critical number that belongs to this interval. And in fact, it is the only critical number because 0 cannot be a critical number. Anyway, we put e to the power half and the end points of the interval, and we find f of each one of them. So ln e to the power half is just half, and we have to replace x by e to the power half and raise it to the power negative 2. So if you do that using the calculator, you will find that the answer is 0.18. Well, if you find ln half and divide or replace x by half, the answer would be negative 2.77 or negative 2.8. And you can replace now x by 4. So ln 4 over 4 square or times 4 to the power negative 2. And the answer is 0.08. So absolute maximum is f of e to the power half, which is approximately 0.18. And absolute minimum is f of half, which is approximately negative 2.8. Another question, and this is the last example. Well, to find the domain, you have to put x squared plus x plus 1 greater than 0 and solve it. But if you check the discriminant of this equation, you will find it less than 0, because b squared 1 minus 4 times a times c, so it's less than 0. So which means it has no real zeros. So it's always greater than 0. In fact, can this value, yeah, it could be equal to 0. How? No, I mean the discriminant is 0, so there is no real solution. It has no real solution. So it will not be ever 0, okay? So it's always greater than 0. So the domain would be all real numbers. It cannot be equal to 0. All right. But anyway, we need from negative 1 to 1. So we find f prime to find the critical numbers. And we have x squared plus x plus 1 over times the derivative of x squared plus x plus 1, which is 2x plus 1. So this is f prime. It's nice. I can see where it does not exist, the zeros of the denominator, but there are no zeros of the denominator. It has no real zeros. But f prime can be 0 if the numerator is 0, which means if x is negative half. And negative half is between negative 1 and 1. So this is the only critical number. And I have negative half, negative 1 and 1. And I replace f. If I replace f with 1, I will have length 3. And length 3 is 1.1 approximately. If I replace x by negative 1, I'll have negative 1 plus 1, 0, negative 1 squared 1, ln 1, that's 0. If I replace x by negative half, so negative half to the power 2 is 1 over 4 minus half plus 1, that's plus half. And if I find ln this number, I get negative 0.29. So the absolute maximum is f of 1, which is 1.1 approximately. And the absolute minimum is f of negative half, which is negative 0.29. That's the end of this section. I hope these exercises helped you understanding the topic.